Hello everyone. I think we have completed half of the course, and now as we have the sufficient amount of the knowledge what machine learning does, it's a good time that you start working on the projects, and I believe that the team has already uploaded the videos and they have started giving you the assignment and the challenges. So in this week you would be having the data where you have to play around with the data, you have to explore, you have to do a lot of stuff at the back end, you have to read a lot of things so that you can, like in Python, if you want to draw a histogram or a scatter plot, what is the syntax which is required, right? So for those stuff you have to explore a lot of things in the Python. For mean, median, I think I've already told you. For mean is already there in NumPy. So you have to use np.mean. Similarly, other functions will be there in other libraries. So that will come with practice, and you don't have to worry, guys, if you are not able to remember the syntax. As I already told you, syntax, it is just a matter of memorizing things. It's not necessary that people will judge you on that. So what's important is you should know the concept, and that is what I always focus on. So few things which I wanted to tell is, before going ahead, I just wanted to understand, till now we have worked on regression and classification, and there will be some more algorithms on classifications. But these algorithms can also be used for regression, but I'm not going into that detail for regression, but I'm using it for classification because in the outside industry people uses all these algorithms mostly for classification. We could see very less projects on predictions, and whenever there is a problem on prediction, most of the people will go with linear regression. Why people go with linear regression? As I told, random forest and decision tree can also be used for predictions. I know that they can be used for classifications as well, but they can also be used for regression. If you remember, I have told you that in one of the sessions, you should understand how they can be used for regression, but I will not be going into that detail. So could you please tell me, for prediction, why generally people use linear regression? What do you mean by generalized prediction? That's not the right answer though, but yes, I would say, please keep trying, always try to think so that you can come up with the answer. So I would always encourage that you guys please keep thinking. And not really, we cannot say that linear regression is neither over nor underfitting. We cannot say that. The reason why we use linear regression is, for example, let's say you know the mass flow rate through the grills for a vehicle. You know this, right? For example, you know mass flow rate. How do we denote mass flow rate in our mechanical language? M dot, right? And let's say that we want to predict the temperature, let's say the overall average temperature of certain components, let's say any component. Okay, now say I am predicting the temperature where my x is mass flow rate. So can you tell me something? If I have a vehicle, as I always tell, I'm not a good at drawing. Let's say that I have a vehicle, and you're driving a vehicle, and there will be a ram air which will be entering into the vehicle, right? So based on this vehicle speed, the mass flow rate enters would be different, right? Can you guys tell me, if I'm driving a vehicle at 35 kmph and at say 240 kmph, okay, now let's say I have m dot 1, this will be greater than m1 dot, or this will be less than m1 dot? Can you please tell me, guys, the mass flow rate entering into the vehicle at higher speed? Will it be higher or lower? Higher, right? Even though if we are not mechanical engineer, we should be able to tell this because the examples which I am taking are very basic examples. Now, we know that mass flow rate here would be higher. So now, tell me, if the mass flow rate through the grills are higher than inside components, say engine, fuel tank, drive shaft, anything, then the temperature of these components will be higher in 240 kmph case or will be higher in 35 kmph case. Where will be the temperature higher? 35, right? So let's go with that same assumption. Yes, 35 would be the higher temperature would be for 35, right? So now, because the forced convection for 245 kmph is quite high, right? I don't know why I am using so much mechanical technical terms today, but seems like I have read an article yesterday and a lot of things refreshed in my mind, which I used to do long back. So a lot of things refreshed in my mind, and that's the reason I'm going with a lot of mechanical stuff today. So now let's assume that the relationship between average temperature and the mass flow rate is linear. So now tell me, will this be increasing graph or decreasing graph? Decreasing, right? So let's say that you have some random, I'm just taking some assumptions always, okay guys? So what I wanted to show here is, say, what is this then? This is your beta naught, y-intercept value, right? And this, what is this? So we know that this would be the slope, right? So what is beta 1 telling? It is directly telling us the slope value, right? So if you remember y equal to mx plus c, if you compare this graph equation with y equal to c plus mx, what is c? Y-intercept. What is m? Slope. Similarly, right? So it is easy to interpret. For example, if I tell that, say the mass flow rate is increased by certain parameters, say by 5 units. Let's say that your mass flow rate has been increased by 5 units. Then you know your average temperature will decrease by say 5 units. Okay, I'm just talking in very simple mathematical terms. Why I'm talking it will decrease? Because your slope is negative, right? Your slope is more than 90 degrees. So tan of more than 90 degrees would be negative, right guys? Do you remember? All silver tea cup. Here all the ones would be positive. All the trigonometric functions. Here only sine and cosecant will be positive, right? So tan would be negative and always the slope would be represented by tan of angle, right? So it will decrease. So what do you think? It is easy to interpret, right? Once you have developed machine learning model, once you have trained the model, it would be very easy for you to interpret once you have the equation. But it's not the same when it comes to different algorithms such as decision tree or random forest, because that would be lot of things would be done with the back end in the algorithm. But of course you can interpret that, but you have to do lot of analysis for that. It's not that you cannot interpret, but you have to do lot of analysis for that. But linear regression is very simple, very easily understandable, very easy to interpret. That's the reason people will go with linear regression. Okay? Yes, we can't use linear regression only because of ease of interpretation. You are absolutely right, but I always try to use linear regression first rather than going with decision forest for regression, or decision trees for regression, or random forest for regression. I generally start with linear regression because by that I will try to understand. I will do lot of exploratory analysis, and then once I develop linear regression, I would be in a position to understand first of all that whether linear regression is performing well or not for the given data. See, we cannot always jump directly to a complicated algorithm. We should start with simpler. First of all, we should understand the problem. Okay, and then we should understand which algorithm needs to be used, whether it's a regression problem or classification problem. In regression or classification, we have to start with simpler algorithm to understand whether the accuracy or the performance what we are achieving is good enough or not. And then we should go with different techniques. Okay, great. So whenever I generally recommend, whenever you try to do the project in the future, always try to implement at least 2 algorithms to understand whether the accuracy what we are achieving is it sufficient enough or not. And then you should check for errors also. Okay, and you should check whether it's an overfitting or underfitting. What's the difference between decision tree and random forest? So decision tree we have already discussed. Decision tree, in this we have seen the entropy and information gain, right? What is entropy? I'm just refreshing few things, guys, because it could always be possible that there could be few things which might come extra when I talk something again. There would be 100% chance that I might tell something new on that. So what is entropy? It's a measure of impurity or uncertainty. What does impurity mean? If you remember, at the end of the classification, when you have looked into the decision tree, we have to make sure that the classes are pure. That means it has to be either 1 or 0. If it is a binary classification, if it is a multinomial classification, then it has to be either 1, 2 or 3. But then the point is, are we supposed to get the exact purity? No, because then our tree would be very shallow and then it would create an overfitting issue. What do you mean by irrelevance? Could you please elaborate?
I meant that our characteristic might not be influencing the output.
Right, you're talking about entropy, right? I got it. So that's the whole point. And then the point which I wanted to make is entropy is just a measure of impurity. How is it helpful for our analysis? Because using entropy, we are calculating information gain. And that's the ultimate goal for us. What is information gain? Information gain is the one which tries to reduces the entropy, and then we understand by that which feature has the more information carried by to influence the output. That is our information gain. Now, what is random forest? The decision tree is just a single tree. So, and then random forest is multiple trees. So I have given you an example. So if you want to buy a car, then we generally don't ask only one friend, right? We will ask a lot of people. Similarly, random forest also works in a similar direction. If you are searching for some mobile and you don't know which mobile I should buy, then you will ask your friends, right? It's not that you will stick to your only one friend. That's the whole point of using random forest. And then it also avoids overfitting. That's the main advantage of random forest. So I've already told the second answer, the advantage of random forest. What is the disadvantage of random forest? Please find out what is the disadvantage of random forest. Okay. One of the disadvantages would be it has to take multiple decision trees running, right? So it will take more computational time. And remaining thing you can find it out. What are the other parameters to assess the classifier? So apart from this, I told you to find out what are the other parameters which people go and look at. So did you find out other parameters for classifier, how to evaluate the performance of a classifier apart from this parameters? Okay, no problem. You can go ahead and find it out. I think I have given one example of F1 score in the last session, which was not there in this PPT, but then F1 score is an important parameter also. And then this was their first project, perform exploratory data analysis and all different classifier regression for the case study given in the session, evaluated based on the performance. But you can neglect this for time being. What you can do is you can just perform the exploratory data analysis for the case study given in the session. In the sense that will be provided by the Roshan. Okay, that will be provided by Roshan. So, but it's not necessary that you have to take the same case study. You can always take any random case study. You can take any and then you can perform exploratory data analysis. It's up to you. The ultimate goal is you should be able to understand the data. That's the whole point. I'm not sticking with the respect to one particular data set. My ultimate goal is you should be able to understand the data. You should be able to play around with the data. Before going ahead to one more classifier, again, I wanted to remind you guys, in this session, we will be only looking at the classifier and how to model that classifier, the concept behind that classifier, and then how to code that in Python. That's the whole purpose of this session, that you should be able to work on any data science project or machine learning project. But there is a separate course on the advanced version where you will be understanding more of mathematics. Behind every classifier, the way we have learned for linear regression, there would be a mathematics involved for more or less all the classifier we should be looking in detail. Okay. In the first, we are taking one step at a time. At this point of time, we should be able to understand the concept and code. Now, I have a question for you guys. Let me open. Let's say that I have a data set which has 10,000 records. Let's consider it's a binary classification problem. Now you have understood the problem statement, you know everything. Whether, let's take a business problem here. Let's say that we have 10,000 different types of brake disc with different dimensions and different parameters. Our objective is whether the brake disc can sustain or not. Okay, let's say that we are doing it for winter climates in Europe. Let's assume this, okay? This is a given condition. So whether the brake sustain or not. Okay, now you might be having different parameters. How would you check whether the brake disc can sustain or not? Do you all know lump capacitance method, guys? So I don't want to go into much detail, but then you know that this one, when a body is considered to be a bulk in the lump capacitance model, the body would be considered as bulk. Bulk in the sense, say the parameters will, let's say this is a brake disc, the temperatures or the different parameters will not change with respect to XYZ direction. It will only change with respect to T, time. So that is the reason we consider capacitance method, we consider the body to be lump. So there what we do, the amount of energy stored in a body will be cooled down using convection, right? Now are you able to recollect this equation, guys? So now this is not T minus T infinity, this will be d temperature, right? So this is dt by d tau. So now this is lump capacitance method which we generally use when the parameters are not changing with respect to spatial coordinates, but it is changing with respect to time. Okay. Anyways, so you can do those analysis if you want to do that. But anyways, these are the different parameters which are, so for example, you already have in your data set. And you have whether the brake disc can sustain this or not using the historical data set. Someone has done the analysis using this 1D analysis, using this lump capacitance method or the test results. Let's say you have test results. Now you have divided this data into 70% training and 30% as test. Now, the important point to understand here is, let's say that, do you remember the threshold probability which I've told you? 0.5 in classifiers. Let's say in the logistic regression, if you remember, let's take a logistic regression, right? We have considered the threshold value as 0.5, right? So let's assume, now the question is why we have considered the threshold probability value as 0.5. So the whole point is, it's not necessary that we should always consider 0.5 as the threshold probability, that if the probability is more than 0.5 then it will go in the class 1, otherwise it is class 0, right? We are providing equal chance, but then is it necessary? Not really. So we start our analysis with a threshold probability value of 0.5, but then let's say, because this is your training data set, you can compare your values also, right? Here while building the model, say this is your y actual, say you got some y predicted, say this is what you are getting, okay? And this y predicted is based on the probability value of 0.5. Say this is your predicted value based on 0.5. Now let's say that you have got different data 1000 something, and then you are predicted based on 0.5, you got this result. While training, let's say that you got this value was y predicted with 0.5 as a predict. Let's say with 0.6 as a threshold value, assume this, okay? You are getting this. Then which threshold value of probability is the right value, guys? 0.5 or 0.6? 0.6, right? So that's the whole point. So we should start with 0.5, but we cannot always restrict ourselves with 0.5. This would be your interview question. Is it necessary that logistic regression should always, the threshold value for the probability should be 0.5? Not really. It's not necessary. Sorry, it's not necessary. So ideally, in real scenario, what you should do is, let's say with 0.1, with 0.2, with 0.3, with 0.4, 0.5, 0.6, 0.7, 0.8, different probability value as a threshold value, you should try to come up with your Y prediction, okay? And then based on that Y predicted value, you should build your confusion matrix. And then you should check for which threshold value of probability you're getting the better performance, and then you should carry forward with that. You should go ahead with that probability value. Isn't it so difficult to do it for every probability value? For 0.1, 0.2, 0.3, it's okay. There are intermediate values also, right? 0.11, 0.15, 0.55. Some models might work better for 0.55 rather than 0.5. So how do I treat those things? How do I understand what should be used? Of course, I know that you can use for loop with different probability values, and then you can come up with a different confusion matrix, and then you can compare the results, and then you can tell us which probability value is a right value. But there is something called as ROC curve. You have to tell me what is the full form of this in next class, okay? ROC curve. These curves are specially meant for classifiers. So what you have to do is, to have a better representation, ROC curve, what it does, on the x-axis you will have false positive rate, and on the y-axis you will have true positive rate. Do you remember what is true positive rate and false positive rate, guys? We should always target for higher true positive rate and lower false positive rate. So in ROC curve, this is your true positive rate, this is your false positive rate. Now, if I have different probability threshold values, and let's say that, what could be the maximum true positive rate? Can you tell me what could be the maximum value of true positive rate, guys? 100%. 100%, that's okay. That means 1, right? What would be the maximum value of false positive rate? If you have a worst algorithm, 1, 1. Similarly, the minimum value of true positive rate and the false positive rate would be 0, 0, right? Now, let's say for different threshold values, this is the one which you have got, the threshold value of probability, say 0.55. Say this is the probability value with 0.5. I'm just giving you an example, guys, okay? Let's say that with this you got 0.5, 1. With 0.5 you are getting 0.75, 1. So which threshold value you will choose in this case? 0.5 or 0.55? With 0.5 you have the false positive rate as 0.5 and true positive rate as 1, and with 0.55 you have false positive rate as 0.75 and the true positive rate as 1. Which one will you choose? 0.5, right? Exactly. So now you're getting my point. So what happens in general, we draw this curve for different probability values, threshold value, we might get different curve, something like this, and then we draw those kind of, we join those points, and then we'll get one curve. Okay. Similarly, let's say this is for logistic regression. You have used logistic regression, different threshold value, you have got this result. Let's say now, I'm just drawing randomly, guys, okay, don't worry about it. Say this is your logistic regression. Now, this is your ROC curves, okay. Now let me take other color. Let's say these are coinciding here. Let's say this is your different threshold values of probability. This is the graph which you are getting. This is the ROC curve which you are getting for random forest. Okay. Now tell me which algorithm is better now. Okay, tell me, area under curve for logistic regression is more or for random forest is more? For which one? Right. Random forest is better. You are able to analyze it, right? Because it can give us the result with very less false positive rate and very high true positive rate. So the area under the curve, for which we have to check the area under the curve, which is called as AUC. So higher the area under curve, better the algorithm. So ROC curve and AUC, these both go hand in hand. Area, you should find out the ROC full form, okay, and area under the curve. So these both will go under hand in hand, and this is the famous interview prop question which you can always anticipate in the interview.